And once again, we're now exhibiting a new horizon of possibility, which is the neurotechnological device space. Each and all of these, what I should let you understand, is engaged by this particular process, which is a real term, integrative scientific convergence. It is a term that a colleague of mine, formerly at the State Department, named Dr. Ashok Vishasta, has been working very, very closely to advance and understand, and it's essentially represented by this neat little cartoon. It's a de-siloing of the capability space. It's also a de-siloing of the opportunity space, both for problems and problem resolution and problem generation yet again. In the past, when I grew up in science, as many of you have grown up in science doing, for those who are sort of more of my generation, you recognize you had fairly discrete silos of disciplinary operation. Those of us in chemistry who talked to those of us in biology, and there was some crosstalk, cross-fertilization, but very often they occurred at the top and the bottom of the silo. Things that occurred within the silo occurred within the silo. Sort of like what happens in Vegas stays in Vegas, what happens in your department stays in your department. More and more, however, we're moving towards this conjoinment model that de-silos the operation and opportunity space and allows for a much more convergent engagement of what the brain sciences can do. And in fact, for those of you working in the brain sciences, you recognize that there's a relatively sort of fluid dynamic that occurs between physics and chemistry, chemistry and biology, biology and behavioral science, and undergirding and perhaps overseeing all of these are both engineering models and computational models. These have been capitalized by this. So it allows us to conjoin cyber science and tech, the anthro and social sciences, natural sciences, biotechnology, and nanoscience and technology in a large integrative model that increases the viability, validity, and ultimately perhaps value of what the brain sciences can achieve in a fairly short period of time. And in national security, intelligence, and defense agendas more and more, this type of convergent approach is being harnessed upon assessment, access, and targeting of neurological structure and function so as to be able to get a better insight to and influence of individuals and groups on a whole host of levels. One of the things that makes this work, as I alluded to earlier, is the use of large-scale data banking and data utilization, what's referred to as big data. Not to belabor the point to excess or in extremis, understand it is used as a force multiplier. In other words, it takes the forces that are there and it multiplies both their capability and ultimately their value and utility as a consequence of being able to utilize large volume data banks, which then are able to engage, assimilate, synthesize, and pull down in real time individual cohort and populational data tiers, and in so doing allow multiple tier integration, multimodal, multi-level, and then also allow real-time access requirements that can be utilized in practice. In other words, we can use these large-scale data integrators to be able to pull information about him and her and him in a comparative way, in a normative way, and also in a way that allows us to then develop various tools to be able to understand how better to access him and her and him, and all of, as you could tell from my New York accent, use